Let's continue with our analysis of the local average treatment effect. In the previous video, I introduced the Angust-Imbens-Rubin model, which is the canonical model for studying the local average treatment effect. And we learned that there are 4 assumptions that have to be fulfilled in order for an instrumental variable estimator to provide a causal estimate. The first is the ignorability or conditional independence assumption, which is that the instrument is as good as randomly assigned. So using the example of Angust's paper on the draft lottery, draft eligibility was assigned by a lottery and was random. Right? This was done for fairness reasons, and lots of balancing tests that have been done afterwards with different types of data showed that this was indeed as good as random. The second assumption is the exclusion restriction, which is that the instrument has only an effect on the outcome through the treatment, but no direct effect on the outcome variable. This is obviously debatable in any particular case, and that's always the hardest assumption to justify when you write a paper with an instrumental variable estimation. The third assumption is an important one, but is one that can be tested, which is the first stage, is that the instrument actually changes the treatment status of at least some people, that you at least have some compliers. If the instrument status does not change anyone's status, then we will see that the instrumental variable estimator does not exist. It does not exist because the first stage is 0. And if you remember, the instrumental variable estimator is the reduced form divided by the first stage. And if the first stage is 0, that fraction goes to infinity, so it's not defined. The fourth assumption is monotonicity. So what does that mean? It means that there is no defiers. There are no people in this example that if they have a low number, as in if they're draft eligible, they would not serve, but they would serve on the contrary if they were not draft eligible. And so think about the classic toddler behavior. Would always do the opposite of what their parents tell them to do. That's these would be defiers, and the monotonicity assumption requires that there be no defiers. In most contexts, and also in this one, this seems plausible. It's implausible. Obviously, there are never takers who would, as much as they would have the lowest lottery number in the country, they would simply not be drafted. And there may be always takers, but that's not inconsistent with monotonicity. What's inconsistent with monotonicity is that some people are encouraged by the instrument and other people are discouraged by the same instrument. That would, with a binary instrument, that would simply violate the monotonicity assumption. And so under those 4 assumptions, the instrumental variable estimator identifies the so-called local average treatment effect. So what do we mean by local here? Local is somewhat, the term local here is somewhat deceptive because it seems to suggest that we can somehow pinpoint where where that average treatment effect lies, as in to what group it actually applies. And we can do this in theory, but if we see an actual data set in front of us, we cannot pinpoint that group. Okay? Why? Well, because we know that the local average treatment effect is the treatment effect on the compliers, as in those people or units whose behavior is changed by the instrument. And for anyone else, we cannot say anything about the treatment effect for always takers or never takers. Now we might say, well, there is no treatment effect if they're always or never takers. But that's not true. The treatment effect for some of these people may be 0, but for others it simply may be, the treatment effect may be positive, but it may simply be very, very small, and so they choose not to take the treatment. And this is something we will learn later in this lecture when we talk about marginal treatment. So the local average treatment effect is different then from the average treatment effect, which would be the average treatment effect in the entire population. So you take the individual treatment effects for every person in this population, so in this case for every man of draft eligible age in the US, and you would say, well, the average treatment effect would take from each person the treatment effect. What's that? The treatment effect, the individual treatment effect is that person's earnings had they served minus that person's earnings had they not served. Right? Obviously, we only observe one of these two. Either they served or they didn't. But the individual treatment effect would be the difference between those two outcomes, those two potential outcomes. And the average treatment effect takes the average across all the people in that population, or then in our estimation in the sample. The local average, and so this is a parameter that gives us an average value for the population we study. Whereas the local average treatment effect can be quite different from that, because now we are not giving every man in the population the same weight, but we only give positive weight, or our estimator gives positive weight to those men whose behavior is changed by the instrument. Yeah? So basically, never takers and always takers, even though they may be actually quite large parts of the population, may actually get 0 weight in that estimation. And whether the local average treatment effect can then be extrapolated to the broader population depends on how different these groups are that get positive and 0 weights. Right? So if we have reasons to believe that it's as good as random whether someone's a never taker or an always taker or a complier, it doesn't really matter. Or if the individual treatment effects are the same for everyone, it also doesn't matter. Because then the local average treatment effect and the average treatment effect will coincide. Also something that we show when we talk about marginal treatment effect. However, if, and this is most likely the case, if there is, let's say, a greater wage penalty to some people when they serve in the army than to others, then we would assume that those people for whom the wage penalty is greatest, they have the greatest incentive not to serve. Huh? And so these are most likely then the never takers. Whereas for those people, I don't know who would be always takers here in terms of economic incentives or so, but certainly the never takers and the compliers will be very, very different types of people. And so we can probably not extrapolate from the compliers, which is what the estimate we're getting, to those who would never serve in the army under any circumstances. So going back to the theory, what the late theorem from Angust, Immons, and Rubin tells us is that given these 4 assumptions, the IV estimator, here in the shape of a walled estimator, identifies the average treatment effect for the compliers. Right? So again here, what is the average treatment effect? You take for each person in the population, you take the treatment effect, the individual treatment effect. So that's that person's earnings had they served versus that person's earnings had they not served, of the same person. We only observed them in one of the two statuses, but we always have to think about what would be the counterfactual outcome. If we observe a person who did not serve, then we need to think about what would be that person's earnings had they served. And the difference between the two is the individual treatment effect. And so the individual treatment effect, the average treatment effect, whether it's local or just the general average treatment effect, is always an average across individual treatment effects. The difference comes when we look at the weights that different estimators attach to these individual treatment effects, to different groups. And so what the late theorem tells us here is that in the estimation, in the calculation of that weighted average, all the weight is on the compliers and zero weight is on always and never takers. Okay, so that's the local average treatment effect. Now that theorem can be proven. Okay, so first of all, we can show this by simply taking the equivalence to a regression whereby we have an outcome y that is regressed on simply the instrument z, so the reduced form. And the parameter that we are interested in is obviously the slope coefficient. Here is beta, and that beta is nothing more than the difference between the outcomes of people who received the who were encouraged by the instrument, for whom the instrument is 1, and the outcomes of those for whom the instrument is 0. And that's the starting point. And what we're doing now is we're gonna split those terms on the right hand side up into the contributions of those different groups, those different compliance groups. So we have compliers, never takers, and always takers. And so we're thinking now about the average. So let's say here the average outcomes for compliers who were encouraged by the instrument multiplied by the share of compliers who were encouraged by the instrument, plus, now here we have the average outcomes of never takers who were encouraged by the instrument times the share of people of those people who were encouraged who are actually never takers, and we do the same for always takers. And so what this gives us then is we can then rewrite this term here as that. Okay, so we have basically the average outcome for people who were encouraged through the instrument for compliers, never takers, and always takers, weighted by their population proportions. And so these population proportions are simply those. We can do the same. So here, so what we've done down here is let's call this A and let's call this B. We have so far looked at A, so that's A. Now let's look at B. that's here, and we can do the same thing. Okay, so the compliers, never takers, and always takers. So we simply break up this average outcome of those people who were not encouraged by the instrument. We break them up into the average outcomes of compliers, never takers, and always takers, weighted by their population shares. Now you may say, wait a second, you're showing us here a conditional probability. How can you say this is the population shares when not everyone has been encouraged by the treatment? Well, I can say this because the instrument is assumed to be as good as randomly assigned, and so the probability of being a complier or a never taker or an always taker does not depend on the instrument itself. So here the probability of, for example, being a complier conditional on the status of the instrument is the same as the probability overall of being a complier. Okay, so from this step we arrive at that one. And so what we're doing now is we have A minus B, and things simplify considerably. Why is that? Well, because if you look here, the average outcome of a never taker will always be the same whether the instrument encourages them or not, because they just don't take the treatment. The average outcome of always takers will also be the same no matter whether they get encouraged to take the treatment or not, because they take it anyway. Okay, so in that sense, this expectation here is the same as the following: I, Y, I1. So these are people who have never takers who have been encouraged to take the treatment. And the same then obviously for always takers. So when you take the difference between A and B, those terms just cancel out. So all we are left with is this difference in the average treatment effect, or is this average treatment effect for the compliers times the share of compliers. Okay. And now what we are putting this together is what we do is we scale this up by the number of people, or the share of people who have actually, whose behavior has actually been changed by the instrument. Okay, so we scale this up by the first stage. If you remember from one of the previous videos, we talked about the moving to opportunity experiment, and we talked about the reduced form, which was that 50% of the people who were offered got the treatment, took the treatment, and then their increase in the outcomes was, we overall observed an increase in the outcome of 10 of all the people who have received the treatment. But this 10, as I'm just gonna write this here, the reduced form outcome, the difference that we observed in the reduced form was 10. The difference in the reduced form was 10 between those people who received the voucher and those who did not. But what this came down to was, it was that for the compliers, for those who actually moved, the average gain was 20, but only 50% of them moved. That's what gives you the average in the reduced form, or in the intention to treat. And now let's think about how we can then scale this up so that we can actually get the average treatment effect for the compliers, and that we have to simply divide it by the first stage, and that's what you see here. This is the first stage. This is the share of people or units whose behavior is changed or whose treatment status is changed by the instrument. And so if we put the two together, so I'm going to just do this up here. So we have here the intention to treat effect scaled up by the first stage. So that's the expectation of DI for those who've been encouraged, minus the share of people who were treated among those who have not been encouraged. And that equals exactly the effect on the compliers, as in the local average treatment effect. And so this is good news. Why is it good news? It is good news because based on a small set of assumptions, some more restrictive than others, admittedly, we can actually identify this causal effect. Right? And as much as people criticize instrumental variables for all sorts of reasons, the fact that it has been used so often in the literature is proof of its success, that with these few assumptions one can actually draw a lot of powerful conclusions in different contexts. But the challenge here is that while it helps us eliminate heterogeneity problems, it comes at the cost of having this local average treatment effect. And so if we see a data set, or if we look at our population, we may be able to determine how many compliers there are, but what we are not able to determine is who exactly is a complier. Right? I can say, okay, 1 in 10 is a complier, and I can say, okay, the compliers must be among those whose treatment status was such and the instrument was such. But I cannot fully say, okay, this person is a complier and this person is not a complier. And that can be at times a problem. And so that's what makes the local average treatment effect so controversial. And there has also been a debate in the economics literature about, you know, the general use and overuse of this methodology, which has often been seen as quite atheoretical. So we get a parameter that is neither of great policy interest, nor does it reflect a structural parameter of an economic model or is related to one. And so that's why it has been criticized. Yet I will show you when we talk about marginal treatment effects that need not be true, that we can actually use the late estimates to answer interesting policy questions that then yield a result that generalizes to whatever population we're interested in. You obviously need a lot of data, you may need more assumptions, but it's possible. And this is where the current research frontier really lies. Now, and also the important thing is here, you know, people also say, well, better late than never. It's late is often simply the best we can do, and it's up to us as researchers to explain and to bring supporting evidence to say, well, to what extent does my late generalize to certain populations? Now let's take this a step further and if suppose we wanted to extrapolate the local average treatment effect to other groups, what are those other groups? Well, we know what those groups are in theory. These are never takers and always takers. Okay? We cannot extrapolate from the compliers readily to those, but we can try and see to what extent in terms of potential outcomes these groups are actually similar. Yeah. So what we want to try and see is what would be the outcome, the average outcome for compliers if they are not treated relative to the never takers. Are they similar? And does the same hold for compliers who've been treated? Are their outcomes similar to the always takers? If the answer to both questions is yes, then extrapolation makes more sense. If the compliers are very different from the compliers who have actually been treated, are very different from always takers, and those who have not been treated are very different from never takers, then the IV estimate just doesn't tell us overly much about anyone else in the population. And then we have to think, well, how interesting is that complier population to begin with? That depends on the context. So, how do we do this? We have obviously certain information in the data. Right? So we have the population distribution of those different groups. So we don't know, again, who in the population is a complier, who is an always taker, but we can determine their shares based on the observed behaviors. Right? Because we observe what instrument status they have and we observe what treatment status they have. Okay? So if someone has not been encouraged by the instrument, and yet we observe some people who get treated nonetheless, then these people must be always takers. And that's what we see here. So that's the share of always takers. Now, those people who have been encouraged by the instrument must either be, and then get treated, must either be always takers or compliers. So that's what we see here. And so that already gives us two groups, right? Because we can immediately get at the share of always takers. And if we subtract them from everyone who has been encouraged by the instrument as well as treated, we also get at the share of compliers. And we can then also, by the same token, calculate the share of never takers. So that's possible. So we can get those population shares. And then also, if you think about it in terms of a matrix where you have the instrument 0, 1 and the treatment 0, 1, let's call these A, B, C, D. For A, B, C, and D, you observe so we observe their population shares, and we observe also what their outcomes actually are, their average outcomes, such as earnings. So we have some information. And if we know those probabilities and we know those average outcomes, we can then recover some of the averages, for example, the average outcomes for compliers who have not and who have been treated. And that's what we're going to do now. So what I'm going to do here is, from that matrix that I've shown you previously, I'm gonna take each element and say, well, what is that average element? What groups does that represent? And what are the outcomes that I can actually see here? Okay, so let's start with the first group. These are people who have not been encouraged and who did not get treated. So these must either be compliers or never takers. And so I can then take the conditional probability. So these are people who are not, apologies, who did not get treated and are not and did not take the treatment. So these are people in A. Right, and so then in cell A you have those two groups, and part of them are compliers and part of them are never takers. Okay, so let's look at this quickly. So we observe here the average outcome for this we readily observe in the data. This we can also infer from the data. Namely, that if we observe someone who has been encouraged but did not take the treatment, that must be a never taker, right? And so that these are basically the outcomes, the average outcomes of never takers who did not take the treatment. We don't know what would happen to never takers if they took the treatment. That we don't know. Okay, so the counterfactual outcome of never takers if they took the treatment, we don't know. That we don't know. But what we do know is what is their average outcome if they don't take the treatment, because that's what we observe in the data. Okay, so that we can do up here. And so I'm gonna just circle in red all the elements that we know. We know this, we know that, and we know all those probabilities. And so from that, we can actually back out, from those first two equations, we can back out what the average outcome of compliers is if they are not treated. By the same token, I can use this equation down here, where again I observe this, and this in the data, because again, if I observe people who were not encouraged, yet they take the treatment, these must be always takers. And so I can take this average and plug it into here. And so I can get then at the average outcome of compliers if they're treated. Right? And the difference between this average and that average up here, I'm sorry, this is getting pretty messy here. That's then the local average treatment effect. Okay? All right, so let's think about this in the example, using the example of Angust. So here we have certain information in the data. So we know the assignment of the instrument and we know the treatment status. Okay, so there are some people, as you can see, there are obviously a lot fewer people that were drafted than those who were not drafted. And so even those who were draft eligible, there was a good few, and actually the majority of those who were draft eligible, so for whom the instrument was won, who actually were not drafted in the end or didn't serve. Okay, now we can then compute from that these probabilities, these conditional probabilities that someone is a never taker or an always taker, and so on. So these are basically the probabilities that I've circled here. Okay, so the probability that someone is a never taker if they were not conditional on not having been encouraged by the instrument. Right, so here we have, for example, we have here people who were encouraged by the instrument, but they don't take the treatment, so they must be never takers. And so we're basically here in this column here. Okay, so the probability of someone being a never taker is 865, which is the number of people who took the treatment and were encouraged over all the people who were encouraged. And that then gives a 0.6888. You can try this yourself at home. Now, what we can get out of so we have this information in the data, and we also have their average log earnings in the data. Okay, and so now what we can do is we want to arrive from these 2 bits of information at that table. How do we do this? Well, we use those formula on this slide that has turned out quite messy. So let me quickly clean it up a little bit. So on that slide, you can again take, for an equation like the one here at the top, we know this average from the average wage, we know this average from that table with the wages, and we know those 2 probabilities, and so we can then back out the average wage of compliers who were not treated, who did not take the treatment. And do the same then for compliers who were treated using this formula at the bottom. You can try this yourself, and you might get, because of rounding errors, slightly different values, but you should arrive at something that looks similar to that. And so here you can see that the difference between compliers, so the difference for compliers between being those who were treated and those who were not treated, is about 0.23, which is approximately 23% wage difference. And this is purely comes out of weighted averages of those numbers here. You may ask yourself, how can there be a weighted average how can 5.69 result as a weighted average of those? But just play around with and plug in those probabilities, and you will see that it's actually possible. Because actually the table here at the top is a weighted average of the table at the bottom. And so, okay, so we have here 23% or 23 log points different. But the interesting thing here is, how do those different compliers who were treated and those who were not treated, or took the treatment and those who did not, how do they compare to their counterparts with the same treatment status? And so here we can see that always takers and compliers are actually quite similar. So the idea is that for compliers, it was basically as good as random who then took the treatment and who didn't. This was purely determined by a randomly assigned instrument. And therefore, if we see that the always takers are similar to the compliers in case they were treated, that means those 2 groups are similar. So they can actually, it would actually allow us to some extent to extrapolate to always takers. So if we observe low earnings among people who would have, among people who had who served in Vietnam, that is not necessarily driven purely by the compliers, but it's simply that the same effect would also have happened to always takers, give or take. The other question is, can we extrapolate to never takers? And the answer is no, or not in a straightforward fashion. And if you think about it, this makes sense, right? So if never takers are those who are either in poor health or have some other reasons why they would never serve in the army to begin with, then these are probably very different from people who would serve in the army if encouraged and otherwise not, so who are at the margin of serving versus not. And so you can see this here. These are, there is a 29 log point difference in average earnings. So the compliers, if they were not treated, who didn't go to the army, had much higher earnings than the never takers, who would have never gone to the army no matter what. And so therefore, it's very, very hard to extrapolate from the compliers to the never takers, because it's such a huge, it indicates simply that those groups are very, very different. So this is a very rudimentary calculation of, trying or a very rudimentary attempt to extrapolate from a local average treatment effect. Now, research has since moved on considerably. And so there is lots of recent work by Magne Mogstad and Alexander Torgovitsky and others who develop techniques to allow us to extrapolate from local average treatment effects in a more systematic way. And we will talk about this when we talk about marginal treatment effects. To wrap up the topic of local average treatment effects for now, let me repeat that one of the challenges with instrumental variables, besides having to find a valid instrument in the first place, is that it identifies an effect for a group of compliers. So it identifies a local average treatment effect, and we don't necessarily know who those compliers are. And that is problematic, because the compliers may not necessarily be a very interesting population to actually study. And so it's important to acknowledge that, and it's important to understand how we can maybe try and get at those compliers and pinpoint who they are through additional statistical methods, and or how we can extrapolate from the compliers to non-compliers in order to arrive at the average treatment effect for a population that we're actually interested in. That will be the topic of subsequent videos.